In this video, we'll be taking a look at another tool that joins data together, known as the union tool. So what does the union tool allow us to do? Well, in short, it allows us to stack two or more tables of information on top of each other. Now, unions can be configured in a couple of ways. So we can either union columns based on column names, i.e., if the column names are the same, then the data will be placed underneath their respective column names. Or you can union based on position, i.e. column 1 from table 2 will be placed underneath column 1 from table 1. Now, a third option we have available is to manually configure the fields and choose which column from one table goes underneath columns from a different table. So first of all, for illustrative purposes, I have created two very basic text inputs which have 5 columns of information. We have ID, item, quantity, delivery date, and table for the first table, and we have the same in the second table, but table 2 has quantity and the delivery date columns switched around in terms of order. Let's now drag a union tool onto the canvas so we can see how it operates. The first thing you may notice is that the union tool has an input anchor that is slightly different to ones we've seen previously. The two little angle brackets indicate that it accepts multiple inputs. So you can union 2 or more tables together by simply dragging the output of other tools, in this case 2 text input tools, to the same input anchor of the union tool. If we click on the union tool and then go across to the configuration window, you will see the first menu we get are the union options. Now, the first example we're going to see is the default option, which is auto config by name. This means Alteryx will look for columns with the same name and align them accordingly. Underneath this menu, you will see we have a properties section, which asks us how we want to handle any exceptions. For example, if fields have different names or one table has more columns than the other, what should we do? Well, you can proceed in a few ways. If fields differ, you can have Alteryx throw an error which then stops any further processing of records. This would mean that a user would need to correct any inputs before continuing. But this is not always what we want, as there may be some known differences and we don't want the processing to stop. So Alteryx allows us to continue processing records and either displays a warning message to the user, which is good for feedback and establishing what the differences are, or you can have it so that it ignores any differences and simply continues trying to union the datasets together. For the examples to follow, we will continue processing records despite any differences in fields, and we'll get Alteryx to provide us a warning message if this occurs. The second option within the properties section is where we stipulate how we want the output to be handled if differences arise between input datasets. So firstly, we can get Alteryx to output all fields, and if a column exists in one table but not the other, null values will be used in place of where values were non-existent. The second option we have is to output a common subset of fields. This output includes only the columns that each input has in common, and therefore if a column exists in one table but not the other, the column will not feature in the final output. For our examples, we will have this set to output all fields. Okay, and the final thing we need to acknowledge is that each data input is given a reference. So table 1 is given the label #1, and table 2 is given the label #2, as can be seen on the connection lines shown here. This is based on the order you drag the inputs into the union's input anchor. So seeing as we drag this text input in first, it is assigned connection 1. In the bottom left-hand side of the configuration window, you can set the output order, i.e. which table goes above and which table goes below. Let's leave it as input 1 on top and input 2 second. When we add a browse tool to the union tool and then run the workflow, you will see we get a combined output. You will notice that despite the ordering of columns being slightly different in the two tables, Alteryx has placed the columns underneath the right column headers, and we now have one dataset that can be used in subsequent parts of the workflow. So when you have column headers that are the same in two tables, for which the respective data relates to each other, auto-config by name is definitely the option to go for. Let's now take a look at the union option, auto-config by position. For this example, I will simply copy and paste the first workflow, and then change the option accordingly. As the name suggests, this option will take the order of columns in table 1 and align them with the order of columns from table 2. Now, seeing as we have different column orders, let's observe what happens. When I rerun the workflow and observe the output, you can see that the delivery date in table 2 is placed underneath the quantity column from table 1, and the quantity column of table 2 is placed under the delivery date column. No surprise here, as we have configured by the field's position. So you would really only want to use this option if the dataset's column headers are ordered the same, but the column headers are labelled slightly differently. And for completeness, I quickly want to show you the manually configure fields option. Now this option will give us the ability to move columns from table 2 underneath specific columns from table 1. So let me copy and paste the prior workflow and change the option to manually configure fields. Alteryx in this example has actually been able to assume that we want columns with the same headers to be above each other. But if I were to move the fields around manually by using the left and right arrows, and then rerun the workflow, we get an output as per our manually configured position. So we've now covered 3 union options, all achieving the result of stacking one or more datasets on top of other datasets. Now in the last video, we explored the join tool, and we have also looked at the concept of left joins, right joins, and full outer joins. Now if you look at the diagrams I shared previously, you can see that the left join is represented by taking all the data from the left table, and where there is a match with the right table, the dataset will be enriched. However, the left anchor of the join tool is represented by this Venn diagram, which looks slightly different. Therefore, in order to replicate a left join in Alteryx, we actually need to union the L output anchor and the J output anchor so that the resulting Venn diagram is the same. So let's do this for the previous example we visited in the last video. If I drag a union tool after the join tool, and then drag the L output anchor and the J output anchor into the input anchor of the union tool, this will perform a left join, where all values from the left table will be present, and where there is not a match, the columns from the right table will be populated with null. So performing left joins, right joins, or full outer joins requires the combination of the join tool and the union tool to get the expected result. This is a very powerful combination of tools that allows us to join disparate datasets together and is used frequently when working with datasets from different sources.